All right, I think we can begin. So we have mixed audience, some in person, some via Zoom. So we'll begin with the first speaker. First thing that I want to remind you is that we are recording this video, this meeting, and it will be shared eventually via YouTube. So please do not record yourself. We will be sharing the recorded video later. So that's the first thing. And the second thing is we have five presenters today for 2 hours. So roughly speaking, presenting time will be about 15 minutes, and it'll be followed by 2 4 minutes of Q&A. I think since we have only five speakers, if you go 2 3 minutes beyond your time, that's okay, but please don't do excessively. So I just want to remind you. So we will begin with the first speaker, Amit Kohli. Dr. Kohli teaches at FU Vancouver, and his research focuses on digital transformation, AI, and data-driven innovation in supply chain and agriculture system, integrating research, technology, and project management practices. Today, he will present how to use data science and AI to transform agriculture. So, Dr. Kohli, please, it's all yours.
Okay, first of all, good morning, one and all here. Thank you so much. I am in Vancouver, Canada. Right now, time is 6:33 a.m. Okay, so let me share my screen here, uh, and let us start over. I hope you can see my screen.
We can, yes.
Okay, so this is the topic of my presentation today, leveraging data science and optimization to transform agriculture through smart technologies. Now everything is smart, smart technology, smart refrigerator. We are talking of smart people. So this is flow of my presentation where I will discuss about what is digital transformation, what are the practices, and I will discuss some case study. So what is DT? What is digital transformation? So digital transformation refers to integration of digital technologies into all aspect of business. So we are talking of AI, we are talking of IoT, Internet of Things, we are talking of blockchain. So this is not actually digital transformation. Digital transformation is integration of technologies plus culture plus innovation plus agility plus people. So it is integration of technology and people. So these are some best practices in digital transformation. So I'm talking of Canadian culture here. Uh, we are contributing about 77% of Canadian GDP, uh, plays a vital role in sustainable livelihood. Agriculture is cornerstone of our global economy. So I'm going to discuss a case study where we did a consultancy and there were few problems given by the organization, and I'm going to showcase how we have tackled that problems using digital transformation technology. So this is a company about company, it's an agriculture focused technology company and so on. Yeah, so let us start with the challenges they have given to us. So these are the three challenges they gave us. One was connectivity issue, other was technology accessibility, and last but not the least, livestock management. There were many other challenges, but I have referred or mentioned here only three of them. Now, what was our objective? Our objective was to bridge the gap between traditional livestock farming and digital transformation. We thought of exploring how smart farming and improved connectivity can optimize farming procedure. And of course, to improve livestock health, welfare, reduce disease, and following ethical standards. The first connectivity issue. So this was the main issue. Why? Because they were in rural area. In rural area, again, we have internet connectivity issue and collecting data, mapping, all these challenges they were facing. So what we suggested, we studied all the provinces of Canada. There are 10 provinces in Canada and there are three union territories. Total becomes 13. And then right now I am in British Columbia. Everything is fine here. But again, when you see the rural area, the connectivity is less. We have 5G, but still in rural area, less connectivity issues. So how to overcome? So we have given a digital plate to them. Okay, so this is a digital plate. Now you think what to eat, what to select. So we have given them various internet providers which can help them, for the internet connectivity issues. Now question comes, are they, how much they pay, what are the cost of service, speed, connectivity? So we did a lot of research and we gave all these things to them. And then again, we have given the comparative analysis of ranges, data rate, satellite, short range communication. This is a digital plate we gave to them. But our recommendation was why not they should use Starlink. Why Starlink? Because easily accessible. These are KPIs for Starlink. Track average connection speed, connectivity tool, battery should be function. So these are KPIs. Power efficiency is more, connectivity speed is more, accessibility is easy if they use Starlink. So we have given them working implementation, of course, via Starlink, and it will boost their data collection. So this was our final recommendation, but it's up to them. They want to use it or they don't want to use it. But we have given them the comparative analysis again on recommendation. Then technology accessibility. We said, okay, use digital transformation, use AI, but they were not accepting it. The problem with the human being is acceptance of change. You don't accept change. Now what to do? So then we said, okay, why not you do training programs? Even we can give them the training program. Why not to collaborate with FDU and do the training program with our faculty? Now, then we studied about share of farmers adopting technology by education. What we found that they are not so tech heavy, so it's not easy for them to accept what we are saying. Again, we did a research using KPMG and other research tools, case studies, and we found that 25 to 29-year age, they are tech savvy, but as you grow older, technology is not acceptable to them. They don't want to change even. They don't want to accept technology. My father he doesn't know how to operate computer, and I told him, "You want to learn it?" And he said, "I don't want to learn it. I don't want to learn even." That's fine. It's not good or bad. Then again, we gave them the training program that, okay, this is the cost of training program. You can do from Coursera, you can do from this. We can provide training program. We can give them the course, everything. And farm management system, FMS portal is also there where you can get this training program. Then KPIs for technology accessibility training. Okay, there's a lot of background noise. Can we mute them, or is it possible to mute this background noise?
That noise is coming from the next room. Soundproof is here is a little bit poor, so sorry about that.
Okay, no problem. Okay, so training completion, technology utilization, these are some key performance indicators. And then again, we did a research and we found yes. And we have also highlighted to them that, okay, if there is effectiveness of training, you should do training because you see that the effectiveness increases once you are doing training. So as per the KPMG report. So again, to convince people, it's not easy. We have to give them some, you know, research work behind the training and all. Okay, so recommendation, periodic digital literacy program, including training sessions, workshops, and educational content to improve the knowledge and skills of multiple stakeholders. Okay, last but not the least, of course, this is training program. 1.7% members were willing to engage in green production. Joining pharma organization boosts adoption rate. These are success implementation of training program, success stories of training program using our research. Now, last but not the least challenge, livestock management, how to manage them, how to reduce the disease. We want that they should not die. Now, what to do? There are a few things. First is radio frequency identification tags, RFID, radio frequency identification detector tags. We can implement, we can inculcate on the nail, on the body of the livestock. We can have GPS sensors. We can have accelerometer to see the acceleration velocity, the movement of the livestock, heart rate monitor, environmental sensors, IoT sensors, ear tag with biometric biosensors, temperature sensors, everything on the body of the livestock. Now question comes, oh, these many things on the body. And then they were really reluctant. And then we said, okay, not on the body, maybe where they are sitting, standing in that atmosphere near to that place. And again, we have given them the proposal of making a app, where from the farmer app where they can see the temperature, the velocity of that livestock. And then we have proposed them this, different types of zones where we can count number of sheeps, and we have given them this proposal so that they know how many they have, and even they can give them the names or numbers. Now, this is what we have in a process of developing a patent for this, where from the face recognition of sheep, we can predict that this sheep is having sickness or not. So this is still in a implementation phase. We are doing a lot of experiments, collecting a lot of data, and what we are finding right now is that as the sheep ear angle changes, angle of ear is changing, from the movement or the change, the angle, we can predict that this sheep is having sickness or not. So this is a prediction we can do under some confidence level, of course, 95% confidence level, and we can prevent them to die. We can prevent them. We can cure them before they have sickness. So these things, we are in a developing phase now, and hopefully we can file some patent out of this. Okay, so we gave them the KPIs, what they should do for 0 to 6 months, 6 to 12 months, 12 to 18 months. And this is the payback period. This is what we have told them. Okay, you want to spend, you should have to spend about 25500K, 255K dollars, and this will be your initial investment over annual benefit. So annual benefit over initial best investment. So payback period within 1 year, you will recover whatever you are going to spend. Of course, return on investment is too high, 78.94%. So in our bank, rate of investment is too less, but here it's very high, which we have proposed to them. And again, this is a roadmap we have given to them, implementation, pilot testing first they can do, and then they can move and make a digital marketing plan, application, delivery, project closure report within 1 year. So these are my concluding remarks. The use of RFID tags, accelerometers, and IoT sensors in sheep farming enhances animal health, welfare, and farm management. However, their deployment must follow ethical guidelines that prioritize animal well-being, reduce discomfort, and ensure that data is used responsibly. It's our responsibility to follow these ethical guidelines. Our goal is to implement a sensor-based systems that monitors sheep in a real time to improve health, welfare, and productivity. But we are going to uphold ethical and regulatory standards. So this is what we have concluded, and I've given you the case study. If you have any questions, please go ahead. And if my chair permits me, I just want to show them the RFID, what we are working on, these Raspberry Pi. These are the models we are creating. These are some RFID, tags. These are some jumper wires, and then we have, this is a model. It's not so, heavy, but we are creating all these RFID tags, doing the experiment, and hopefully we are going to implement all this in our. And once we get the funding, of course, we are going to implement all these things. Okay, thank you so much from my side. And if you have any question, please let me know, because I prefer implementation of my research instead of writing papers. Of course, we as a researcher, we have to write papers, but I try my best to give something back to the society, something we need to do for the society. Last but not the least, I always say that please have dreams in your heart, not in your eyes, because when you cry, dream scatters, but in your heart, it remains forever and ever. Thank you so much.
Thank you. Any questions from the audience?
Okay, so I got what is the current stage of your project? Yes, thank you so much for your question. So what we are doing is, we are doing all the experimental work, and we are waiting for the approval from the this company. Once we get, we have given them the proposal, but once they say, okay, we are ready, and they are going to provide us the funding, then of course we will. Right now we are just making models, and you have seen that, this is not very fancy, but still I am trying to do at my home all the programming, coding. But once we get good funding, then of course I will be collaborating with some companies, and then full implementation part will be done.
Any other questions?
AI, on the other hand,
I actually have a question. So how do you compute the ROI? So how do you compute the original return on data gathering?
Okay, let me now show you the presentation again. So I have added the formula here of return of investment. So this is the formula. We have calculated total benefit over time with annual benefit times number of years. ROI formula, total benefit minus initial investment over initial investment, final minus initial over initial into 100. We are reading this from 10th grade, final minus initial. So same thing. We did this, and then we found this ROI.
Garnered by.
Okay. All right. Thank you. Any other questions from the audience? All right, thank you so much. And then we will move on to the next presenter.
Okay, thank you, sir. Thank you so much for giving me the chance, and I'm also obliged to FPU for arranging such a great conference. Special thanks to the chair and all the members here. And if anyone is interested in doing collaborative research with me, please reach out. I'm in Vancouver, Canada. Thank you so much, sir.
Thanks so much. Yeah, next presenter is Professor Jack Chen. Dr. Chen has a background of statistics, and his research interest lies in using statistics as a tool to facilitate hypothesis tests, such as test administration, response scoring, data analysis, and test interpretation. His talk today will be on the principles of logistic regression that you can use in machine learning.
You're going to show the slide on.
As you prefer. If you want.
Yeah, you can show it for me.
So, yeah. You can just join my Zoom. My Zoom is could you join using Zoom?
About 4.6 with that according to the paper.
And my Zoom number is 634 415 9711.
We are digging the same hole, but we're digging deeper. So this concerns me as someone who wants to augment research, wants to augment human thinking.
Okay, you're in and you can share.
First thing that we need to develop is the ability to use judgment, right? Judgment effectively, I think, in this era where AI is out. Judgment becomes one of the that we must upgrade. AI is quite spit out the answer, but then it's the human that basically has to judge whether in the context of what they're exploring, what they're doing research.
Okay, I'm going to talk about how we can use the logistic regression in our machine learning. So I'm going to follow this outline, talk about the task to classify, and we're going to do a logistic transformation and logistic regression and the interpretation of the parameter and finally some summary. So basically, logic regression is used to describe data and explain the relationship between one dependent variable and one or more independent variable. So it is used to predict the probability that a given instant belongs to a particular class. So even though it's like a regression, so it's a predictive analysis. And even though it's the name is regression, basically the algorithm is used for classification. So logistic regression is named for the function used at the core of the method. That's the logistic function. And logistic function has this, it's a particular case of signal function and has this formula. It's 1 over 1 plus e to the power of negative x. And e is the Euler's number. So this is the curve of the logistic function. So the function can take any real number and match the value to 0 and 1. So but not 0 and 1 is 0. So this is really a cumulative discrete function. So the logistic function, logistic regression, tries to fit a line that separates the instant that has a y and to those that equal to 0. So we call this data linearly separable. So the input value X are combined linearly using weight or coefficient value to predict an output value Y. So the key difference between linear regression from this logistic regression is that the output is binary. So it could be 0 and 1, true and false, or plus and fail and such. So below is example logistic regression used. So basically we are going to do a linear regression on the value X become a Z. Then we use the logic function to transform to predict the value of the probability P.
Dr. Chen, some of the audience wants to see you while you're presenting, so I'm going to mute that.
Like this.
Okay. That's correct.
Okay. So basically, we are using a linear transformation on value X. Then we're going to do the logic transformation to predict the value P. Okay. So basically, the coefficient of B0 and B1 are calculated by the maximum likelihood estimator. So the estimator is the product of the probability that the instant of success times the probability of the instant that is failure with 1 minus the probability of success. And usually we take a log of the maximum likelihood function to become a logly likelihood because it's easier to compute. Because in general, there's no closed form formula to calculate the estimator B0 and B1. So we got to use solve the problem numerically and basically by a gradient descent. So this is basically a linear regression, right? We have a simple regression, just one dependent variable, or multiple regression. There are multiple independent variables. So we have observed data, then going to put a line through it. So because for logistic regression, their output is only 0 and 1. So this example said that we're going to predict whether a person passed the written the driving test with the hour or study. So here the output is 0 and 1 with the x-axis is hour or study. So we're going to study with the linear regression. So with this input data, we have the line just pass through this one here. So we can say that anything below 0 just become 0, and everything become 1 just become 1. And we got to transfer the data in between to predict it's going to be a 0 or 1. But every value has assigned probability. So in this case, we want to transfer anything below 0 and anything before 1 use the transformation so that we're going to assign a probability to those instance. So basically, this is the result of the logic transformation. It's a line but become a logistic curve. So basically, again, this is 0 and 1 data. Then we're going to use this logic transformation, and you can see the output is a logistic curve, right? So basically, the logistic regression, the logic P or the log R is the log of the P over 1 minus P. It become B0 plus B1 times X. So the assumption is that the log R and X is linearly related. So that if the R, P over 1 minus P equal to K, then basically we are saying that for every K pass, there should be one fail. So this is R. And you can see that if for every unit increase in X, the logs R increased by B1, and we can write the exponential function in another way, then basically we are saying that for every unit increase in X, the R increased by e to the power of B1. So basically we are modeling the probability of the default as a success. So in our example, we say that the person take a written driving test. So we want to model that by the hour or study, what's the probability of success? Then we can write the formula as conditional probability that the result equal to pass given the hour or study. So we can write another way. So basically, we started with the formula, the first one, probability is the result equal to pass, even, hour, or study. Then we're going to change it to numerical, say that y equal to 1 is success. Then hour or study is represented by the variable x. So we're going to transform this logic function. So basically, the probability of x is equal to 1 over 1 plus e to the power of the z value, okay? So if we want to say that in our example, say that the person give a 3.75 hour study, we want to predict what's the probability of pass the exam or whether he's going to pass the exam or not. So we're going to plug in our formula. We say that it's 1 over this e plus e to the power of negative z. And we use gradient descent to estimate the value of B0 and B1. So we obtain these two parameter values. So we plug into the formula and we get that 0.8270. So basically that there is a very great probability, almost one, that the person with 3.74 hour of study will pass the test. So even though we can use the probability directly, but this is binary logistic regression. So eventually going to have a complete firm result. So we can just scratch it with 0.5. So if the probability is greater than or equal to 0.5, we'll say it's a pass with 1. Less than 5, then at 0.5, then there will be a fail with 0. So basically, we use 0.5 as the cutoff value. So if the false positive is a concern, then we can use a higher cutoff value. You can change to 0.055 or something. So this is a result, right? So we use the logistic regression with the given data. We're going to come up a logistic function curve with the parameter estimated value. So right now we want to estimate the person study for 2 hours, 3 hours, 4 hours, and 5 hours. What's the probability or whether they're going to pass the test? So in this one over here, like we're going to map to the function value with the parameter we estimate. We're going to calculate what's the probability the person going to pass the test. So with this transformation, we're going to get the probability on the left-hand side. Then we're going to use the cutoff value at 0.5 to see whether it's a 0 and 1, and 1 is a pass, then 0 is a fail. So we also have the numerical value to calculate R. So we say the R for this particular case, given the B0 and B1 value, it's 4.713. So basically, we are saying that roughly for every 5 passes, there should be 1 fail. That's the information from the R that is given to us. Also, that we can write the R this way, basically separate the parameter of the exponential distribution. So basically, we provide the number. We say that the R in the second term, e to the power 1.5 is 4.5027. So basically, it's saying that for every increased hour or study, we're going to increase the R by 4.5. So the example is that if we study for 3 hours and 4 hours, the R will be between 1.54 and 6.94. Basically, we increase by 4.5 times. So if we want to use multiple regression, it will be the same principle, but instead of just one independent variable, we will have more than one independent variable. Just assume that all other variable is hold constant and just change one variable. But because there is more than one variable, we need to be more careful to interpret the information from other coefficients. So in our case, we use binary logistic regression. The output just 0 and 1, just classified to 2 different values. But logistic regression can also use to classify multiple classes. Like you have vegetarian, non-vegetarian, or kosher, or some other classification case more than 2. Also, we have ordinal logistic regression, like we are ranking the performance of a hotel, like 1 to 5. You can use this to do a ordinary logistic regression. So summary, the machine learning is closely related to applied probability. That is, we are learning probability from data, and training is closely related to parameter estimation and involve optimization. Basically, we are using a gradient descent to minimize loss function. Okay, so linear regression and logistic regression provide an excellent opportunity to study and understand the concept underpinning the neural network. In machine learning, a neural network or deep learning is many logistic regression function pieces stacked up on each other. I think that's all I have. Any question?
Could you mute yourself? All right, any questions from the audience? Right.
You mentioned about the linear regression only, but there are different type of regression function we can use for machine learning application too.
So basically, if you go back here, they started with linear regression, but linear regression and logistic regression are basically 2 different types of regression, right? So we are saying in logistic regression, you can have 1 independent variable or more than 1. So the input here could be multiple independent variables. So linear regression, if you have a simple regression, just 1 independent variable, right? If you have more than 1, you have multiple. And so when I estimate this v value over here, this could be become a multiple, so I have more than 1 independent variable. Just become like v2 times x2 of x2.
Yes. Thank you.
You used the sigmoid function in your presentation.
This one.
Sigmoid function.
Yeah.
Can you use any other nonlinear functions for the same
No,
purpose?
that's why they call logistic regression. Logistic regression, because they use logic transformation. So if you use any other type of function, then it will be
different.
It will be X regression instead of logistic regression.
I see. Yeah.
But you definitely can use other kind of transformation.
Any other question from audience in person or Zoom? All right, then let's thank the speaker. He's actually here. All right, thank you. Okay, and I think she's not here. So next speaker would be Nandini Chanaratnan and Sahana Varadaraju. So are you here in Zoom? Yes. Okay, thank you. So Nandini is a programmer analyst at FDU and also a web application manager at FDU, and Sahana Varadaraju is a senior cloud app developer at Rowan University. Their expertise is in cloud computing, DevOps, and AWS services. And their presentation today will be about AI policy chatbot. So it's all yours. And please unmute yourself. I'm going to mute the Zoom card.
Good morning, and thank you all for joining us today, both in person and via Zoom. I would like to extend my sincere appreciation to Dr. Stubbs and Dr. Won Joy and the organizing team for hosting this AI symposium on our campus. It is my pleasure to welcome Sahana Varadaraju from Rowan University, who will be co-presenting with me. Together, we have explored several AI models before selecting the Notebook LM to create an AI policy chatbot that enables users to search and ask questions across PDF documents. So let me just start off by showing what are the limitations of PDF documents and why this chatbot would be so helpful in any institute, in any organization, particularly in the educational institutions. I'm going to share my screen right now with just looking at, give me 1 second. I just have to open up this. Okay. So, for example, here I have multiple PDF documents. These were the documents that I downloaded from our HR website. This is public information and public PDF documents. For many people who review documents every day, it is kind of hard for them to know exactly what is in the document. And spending hours together just looking through the documents to find the essence of the document. For example, if I wanted to know after being hired, when can a person request a leave? So the Adobe document itself, Control F or find, would never give us an appropriate answer. Similarly, like if I say, can somebody hire friends and family? Of course, the PDF document really doesn't respond. These are the limitations. Some of the keywords that I typed, and every time I use find F, it doesn't really retrieve any knowledgeable answer. So the solution to this limitation is what we have is the AI policy chatbot. AI policy chatbot is based on Google Notebook, and I just wanted to know if you're able to see the presentation. Are you
Yes, we
able?
are. So
Okay.
we see your entire browser.
Okay,
That's what I mean.
perfect. So
If you
okay.
want to present it as a full screen, you
Yeah,
might want to click the present button.
yeah,
Thank you.
I'm just doing it. So the AI policy chatbot is, okay. Just wanted to confirm everybody is viewing this. Okay. Perfect. This enables the users to query against the PDF documents. It actually, the architecture, we would like to show you how exactly this Notebook LM works. So I'm going to go back and to the chatbot itself. This is where you can see the live chatbot. For example, if I choose the exact same questions that I had right here in the PDF document, okay, and I put it right back into the chatbot right here, and if I ask a question, what is a poor job performance, right? It goes through the entire document, all the PDF documents that we have uploaded there, and it gives exactly the context and of that document. This is not just a keyword search, but a semantic understanding and the answering via a chatbot. So basically, if I had to really go through the entire document, it would take me quite a long time. For people who are crunched with time, they could use something like this to kind of get the essence of the document. Here, if you see, you also have the page numbers of exactly and where this is picking this information from. That means that the question and answer, the query and answer is guarded within the documents that you have uploaded to the Notebook LM. So this kind of reduces any kind of hallucinations or any data that doesn't belong within the context of what you have uploaded. So you can see that this is a chatbot that will answer based on the documents that were uploaded. So now we are going to present what is the technical architecture behind the Notebook LM that enables this to retrieve the answers and to kind of to demonstrate the accuracy of the answers that it is providing. We would like to demo the actual architecture behind the Notebook LM and how it works. So this is the big picture. Notebook LM is built on the RAG architecture, which is the retrieval augmented generation. It combines all the semantic search with the large language model, Google Gemini in this case, to answer any questions. And it is strictly based on what you have uploaded. So you upload a PDF and you query, and then this query is converted into a vector search where it is saved in the vector database. Then a large language model retrieves the answer based on what you have uploaded with a verifiable tag to where the answer is coming from. So this is the foundational model, which uses the Gemini 3. The Gemini 3 provides extreme speed and long context handling in terms of lengthy documents. It also uses a transformer core, which in fact which enables massive processing speed, and it generates the answer based on for the queries that the user is asking. And this model is also multimodal support, which means that you could use PDFs, audio, Google Docs, or you could just paste the text into the Notebook LM. So what the process behind the Notebook LM is, once you upload the document, it parses, the PDF parsing takes place. And if it is an image, you can use the OCR to convert it into a text and you can upload it. And then there will be an intelligent checking where it splits into chunks. The data is split into chunks and it is saved with a proper metadata. I mean, document ID, page number, section title, and the chunks. So you will see the exact code in the following slides. So you can see how the PDF is broken down into smaller chunks. So it makes sense, or there is a semantic comparison between different texts that is in each of the PDF documents. And then this is where the embedding happens in the transformer model, where it is embedded, the chunks of data is embedded with a vector ID or vector dimension. that'll enable for that intelligent answering when you query the PDF. So this is the chunk metadata structure. So each document chunk, for example, if you see there's a text when I query, employee must submit reimbursement within 30 days. That is the text, right? For a question like how long before an employee can, how long before the employee can request a reimbursement, something like that, you can see how the chunk ID, it creates a chunk ID and then the metadata has the page number, then the section, which is the reimbursement policy. In the PDF, it is very important to have the headers so it understands what we are referring to. And then it also gives what is the start character and the end character of that paragraph also. So in this way, we kind of know that it is actually retrieving the answers from the documents that we have uploaded, and it is able to understand what we are asking for and extract exactly what we are looking for. Both document chunks and the queries that the user is inputting are then converted into a vector using the embedding model. So if there is a similarity between two paragraphs, it uses a certain kind of embedding. So they have the similarity, and to identify that similarity. So when a question is typed in by the user, it knows to retrieve those passages with a similar meaning. Vector index and ANN search, all the chunks are embedded and stored in the vector database. And the notebook LM uses the approximate nearest neighbor ANN search for up to sub 100 milliseconds retrieval scale. So the way it works is where it queries the vector database, retrieves, it also attaches the question, and then it retrieves the answers from the vector database, enabling very fast response. Now I'm going to hand it over to Sahana to continue the rest of the presentation. Thank you.
Hello, everyone. I'm Sahana Varadaraju. I'm a senior application developer at Rowan University. And thanks for giving me this opportunity to present. I just want to piggyback on what Nandini was talking about so far. So if we want to compare how we work with these policy chatbot, so you can imagine that we can separate this out into two phases. The first phase is when you actually upload your document. So if that's the first phase we are looking at. You log into the Notebook LM. You need your Gmail account for this, and then you upload your policy. It could be a PDF, it can be a Word document, or any sort of other modality that we can have. Also, something to think about is that these PDFs are not just text, it also stores images. It can store, what I'm talking about is multimodality and the convenience in using the multimodality into the Notebook LM. And the next step would be that these documents will be split into smaller chunks. Typically, it's between 300 to 500 words with each of these chunks. And then there is also a concept of overlap. Why do we need overlap? Overlap is something that's needed to retain the context. So, for example, if you have a chunk about a policy that talks about vacation days, and your document has, say, around 5,000 words, for example, and you specify the chunk to be, say, 500 words per chunk. So what happens is that when it actually gets into the next chunk, it is important that it retains some information from the previous chunk. So for example, if you have an overlap of say 50 words, which means that chunk one has 500 words, but the chunk two has new 450 words, but then the previous 50 words are taken from the previous chunk. This helps to retain the context when the search is actually made on these chunks. So all these chunks that are created, it's very important to have these chunks because some of the disadvantages when you literally load the document and ask to search is it becomes very tedious. It tends to hallucinate. It tends to give you an answer that doesn't make sense, but it is very close to the truth. However, having chunks kind of gives it a smaller proportion of information to process that information and give you the right answer and not hallucinate. So these chunks are in later on are stored in something called as the vector database that Nandini already mentioned about. So the way you and we understand the words as word, let it be English, Chinese, Spanish, or anything. These words or the letters or the alphabet is something that we can process, but the AI models, they don't understand in that way. So what they do is that they take these words and they convert, we convert as part of natural language processing, that gets converted into a numerical representation, which is what the machines understand. These numerical representations are called embeddings. And the way they look like is a vector. Those who are familiar with the vector, it's basically, you can think of a space, and in some space, there is a vector representation of that information. In a very simple words, say, consider an example of a cat and a kitten. All right. So if we are taking the cat as a token or a word, and if you want to represent this numerically in a multi-dimension space, you will have a bunch of numbers associated with it as a vector. And then you want to represent a kitten, it's very possible that they are very close to each other in that multidimensional space. And I know that cat and kitten are close, but how do the machine know that it's close? It's all based on the numerical representation. So usually these vectors are around 768 to 1024 dimensions. By that, what I mean is that it needs those many numbers to determine the property of that particular token or an object in our case, which is a cat. So for example, a cat has 2 ears, it has whiskers, it has 4 legs. So all these are some kind of a property of that object that are also represented in that vector itself. So if you think that the cat and kitten are having almost similar vector numerical representation and they are located in a very closely, they are located in a very close space in the multidimensional space. Some of the difference that you can see with that is like, for example, the size, the age, and other information that would come along that would differentiate the cat and the kitten. So that's how these embeddings or the vector representations are stored inside a database called as the vector database. It's basically captures the meaning of those tokens or the words. So that's a very simple token. I'm talking about just one word, but then in reality, we look at millions of words. We're looking at chunks of data. And in our case, we're looking at around 500 words and having those kind of representations in the vector database. The next thing is that when all these chunks are stored in the vector database, now when a question is asked, right, these questions are again converted into the vector itself, the vector numerical representation. So when Nandini asks, what's the policy or how many vacation days do we have? All these words are considered as token, and again, they are converted into vectors. Again, something that the machine can understand. Now, I have a question with the numerical representation. I have a database with all these chunks, and these chunks are something that are indexed as well. There are different methods to index them, which I will go over later. So when the question is asked, having certain vector representation of the information, and then there is a bunch of vectors over here, based on certain indexing methods, it is going to pull those information. And what we do is there's something called as dot product or the cosine similarity method that we use to check that this question can be answered with this answer. So once we have that, the solution that comes up, this solution is again passed into the notebook LLM or the Gemini model that runs behind the scene. It converts those words, those numbers into the words using something called as NLU, which is natural language understanding, which is the opposite process of natural language processing, where we convert from numbers into the words. And that's how it comes to us, and we see the answer. So with respect to construction context, sorry, Nandini, can you share the screen?
Yes.
Yeah, with respect to context construction engine, the notebook LLM is pretty strong at context itself. They are highly grounded. They don't deviate. They don't give you answers that is outside of what is needed to be answered. In terms of notebook LM, it actually uses these many token context window. What is meant by context window is it's kind of a range of information that can actually store in the memory of the data, in the memory of the model, beyond which it would hallucinate. Like in the previous presentation, we learned about gradient descent with respect to linear regression. This is something that applies here as well. Beyond certain context, the gradient descent problem arises because the gradient diminishes every time it goes behind. So having the context window, having a large context window is always a plus. These days, things are not, the models are not, depending on the context window itself. They are moving towards something called as reasoning and planning. It's more like us not training the model, it's learning on its own by reasoning itself and making a plan of what should be the answer for it. But in this scenario, the context window is something that plays an important role. So you can see that it's, yeah, when you're answering, it's always a grounded information that comes in. Nandini, can you go to, yeah.
Yeah, changed it.
So again, going back here, Notebook LLM is strongly linked to RAG, Retrieval Augmented Generation, which means that we can expect it to always give us a grounded answer. So when you see a difference between LLM with RAG and without RAG, with RAG, it's prone to hallucination. So if I ask a question about, can you tell me what's the policy for not attending this term, without actually giving it a source of information, it won't say you don't expect model to say, oh, this is not right. I don't know what the answer is unless you have something that is put into the place. You would get an answer which is some answer that is very close to the truth, very believable answer, but it's not. However, with RAG, you are actually telling the LLM that this is the source that you need to depend on. And if you don't know the answer, you're not getting the information, then you can have some kind of fallback which says that it's, yeah, I don't have this information or I don't know the answer. So Notebook LM is kind of very strongly associated with that RAG. It doesn't deviate from the facts. Next slide, Nandini. Thank you. And you also saw that when you saw the demo, you could see the citation. This is again an additional confirmation of how you can have the grounded answer, just pointing out to the documents that it is pulling from. Again, going back to the architecture behind it, it all comes back with the chunk itself. It gives you the information based on either one chunk or multi-chunk, multi-PDFs, multi-documents. It doesn't matter, but it's all with respect to the indexing that happens. And citation, again, like I said, it gives you a kind of a extra confidence from the LLM that it's something that's coming from the right source. All right, so yeah, when you saw Notebook LM, you can see that we just don't deal with one PDF or one policy. It spans across multi-document and multi-policy. The way this, the way this works is that say you have policy about academic constraint, or you have a policy about financial aid, and then you have a policy about how do we go ahead and register. All these policies are PDF or any sort of documents. They all actually go into the same vector database, and then the indexing happens on these database. Now, this lets us to have cross-document questions. So you can ask, when can I attend this class? I'm on vacation. And what happens to my registration status? So you can ask questions that has solution in multi documents, but we would expect the LLM or the Notebook LM to take care of this because of the architecture that runs behind. So having the same shared vector database, you're actually placing the information in the same multi dimensional vector space. So think of it that like a person A knows about the policy, about the academic constraint, person B knows about the vacation. You need two-person to actually answer one question that has information with both of them. Instead of that, having one space, one person knowing all the information kind of helps with the search. It gives you a relevant information, and again, it doesn't hallucinate.
Next slide. Yeah.
Yeah, and Notebook LM, it follows it runs on Google Cloud Platform. Vertex AI is one such platform which helps us, which gives you the ability to scale and then, give you a platform or some kind of IDE to build or play around with the models. Vector indexing is vector indexing is a way to actually work with the indexes. So like I said, it's about a point in the space, and when they are having similar meaning, it's about points being close to each other. One such example was the cat and kitten that I said. So Nandini showed you about how the traditional search happens, right? So you look for something, it matches with the keyword and it responds. If it's there, it's there. Otherwise, it's not. However, in this indexing, we do something called a semantic search, or Notebook LM does semantic search. It's much more than the traditional search. It looks for the meaning, the context behind it, and it looks for the semantic, and then it gives you the result. So if I ask for vacation days, for example, it matches accordingly with different scenarios, understands what the question is, and not just with the word vacation days. It doesn't look like that. So one of the things that one of the strategy that is used in NotebookLM as well as in other places as well in different kind of vector search is something called as ANN, which stands for Approximate Neural Network. So approximate nearest neighbor, approximate nearest neighbor. So what it does is that among all the vector entries that you have in the vector database, it looks for almost close vectors. It doesn't, that's why the word approximate nearest neighbor. So it looks for something that is of that region, not entirely the exact answer that you're looking for, but it kind of comes down to a smaller proportion of information or the smaller proportion of the vectors that is useful to answer these things. So it pulls out those chunks that come in. So it's not always like 100% perfect, but it's fast and good enough to search the result. So that's why you can see that the word, it's called approximate nearest neighbor. It looks for that certain distance and it kinds of filters out to make things faster for it. Scan is something that is Google's version of ANN. One thing that is explicit in this scan is that they have a larger semantic search. It's more of an enterprise level. So yeah. All right, next slide, Nandini.
Sorry. Yeah.
Yeah, so I think some of you had questions about privacy and data isolation. So NotebookLM is want to answer that it's Google. I don't think they have proprietary on the documents that we have. I do agree that it has to. We propose NotebookLM for documents that are publicly available, but then there are other strategies to keep them secured as well. Think of this like, Google Docs or Google, if you have an account to it, it's all secure to it. Regarding training the models with the information that we are placing in, I believe, I mean, I can look for it, but I believe that that's not the scenario unless it's, you specifically enable that, but usually you don't enable them. By default, it's not enabled. All right, yeah, I can.
Yeah.
So if we actually look at building this on our own and not use NotebookLM, yeah, it's almost the same process that we use. We can parse the PDF, chunk it using different techniques like LangChain and all, and then you can use any embedding model. We have some defined embedding models, text embedding models from OpenAI. And then you can use different vector database such as Phase is something that is easy to use. And then we can have grounded information to channel it with those chunks that are stored. Yeah. This is just like an example of what you can do behind the scenes if you have to do it ourselves. Right. Yeah, go ahead.
Yep.
Yeah, it's having NotebookLM, it gives you grounded information. The source is mentioned, so that is transparent. It also has a larger context window. We can claim that it is secure and private because of the access and the sharing restrictions that you have. There are some drawbacks to NotebookLM as well. You cannot customize it. We don't have API as of now with NotebookLM to use it to our usage. And yeah, so yeah, but overall it works out well and easy when you have public data available. Thank you.
Thank you. If you have any questions, we are happy to answer. Yeah, it doesn't have an API integration, but it can still be used as a link from any of the learning management systems where you can link it to Notebook LM for any kind of querying within the documents, or even for an institution level policy kind of comparisons, or there is a version control. I wouldn't say it's completely automated. There is manual intervention, especially when you have to replace the PDFs with the newer versions and keep it current. But overall, this is a very easy implementable solution for any administrators or students, faculty who would like to leverage, and when they are reviewing tons of documents, especially to query and get the answers very quickly. I think this is a great solution for higher education space, especially for research and also any kind of sciences where they have tons of material to review and to understand the context of those documents. Yeah, if you have any other questions, please.
I believe Dr. Mao left a question in the chat.
Besides Google Notebook LM, are there any other RAG products? Yep. Rahana? Hello. Yes.
So yeah, sorry, I'm reading the messages here.
Yes.
I see these three policies can also be easily implemented with 3 agents using Agentic AI.
Right.
Yes, we can implement on our own. Definitely we can do it. But it's based on my experience, Notebook LM is something that is very easy and very quick to use. Definitely we can use Agentic AI to implement the policies. Like we do have one version where we are using our own Agentic AI to do this. However, when you actually do it on your own, there are a lot of things to consider as well. Development is the easiest part of all of these. Once it's developed, checking for its correctness and grounded answers is something that would definitely take a lot of time and effort from the team as well, which is much easier on the LM side of things. And I hope I'm not missing any question.
I think that's the only thing. I think besides Google Notebook LM, that's it. Do you have any other questions?
Any other questions from the audience, in-person audience? If not, thank you so much, and we will move on to the next speaker. Thank you.
Thank you for your time. Thank you very much.
Okay, our next speaker is Dr. Tamraparni Dasu. She is a data science expert specializing in computational statistics, machine learning, and data quality. She retired as lead inventive scientist after 31 years at AT&T Bell Lab and now teaches at FDU. She will present a mathematical and data foundation behind AI today. Dr. Dasu, it's all yours.
Thank you. I'm going to share my screen here. And let me go into the presentation here. Okay, good morning, everyone. And, thank you for attending our talk. And I want to thank FDU and Christopher Stubbs and Dr. Choi for making this all happen. So I'm Tamraparni Dasu, and today I'm going to talk about a textbook that I co-wrote with my colleague Geeta. She's here. Hey, Geeta. And this actually addresses the pillars that Provost Rifkin spoke about this morning. This textbook is intended to bridge and connect the basics of data and statistics with AI. And the way we visualized and conceptualized this book is in terms of making it accessible to a diverse audience with different academic backgrounds, but at the same time, making sure that there is no loss in the rigor, mathematical or other types of rigor. So we explained a lot of things from first principles. And I'm going to talk a lot about that because this book is intended for students, for teachers, for graduate students, and also for non-math, non-STEM majors as well, because it's very heavy on applications. And I'm going to focus on that a little bit. But before I do that, I want to talk about my co-author, Geeta Murthy, Dr. Geeta Murthy. She has an ED in instructional leadership, and she has been the director of the math program, K through 12 math program at Herricks District in Long Island, where she acted as the director of the program. She mentored teachers, she trained teachers, she hired teachers, and she also taught math herself. So when we started talking about this topic, it was motivated by the fact that we know that AI is ubiquitous. Everybody's going to use it in some form or the other. In fact, we are already using it when you look at GPS or you look at, text completion that's on our autocorrect and all these things. They're all kind of small applications of AI. And going forward is going to be actually permeating our life even more. So it's important for all of us not only to use AI responsibly, but also to have some fundamental understanding of what goes into this. And it is possible to do so to build on, say, for example, the topics that we learn in high school, and to build on that to create this textbook, which is accessible to many people. And it's actually done. It can be taught at different levels. It can be taught purely from an applications perspective. It can be taught from purely a conceptual perspective. And at the same time, it can also be taught from first principles and with great focus on fundamentals. So all of you can see this, right? So if you look at this, there is a strong interplay between the fundamentals of statistics, data, and machine learning, and the AI applications as they are emerging and as we see them now. And so one of the things we wanted to do is, instead of using toy examples, we actually wanted to take real world examples, drawing from, and I'm going to talk about this a little bit more, drawing from, for example, applications in space, applications in fashion, application in history, applications. Pretty much AI is everywhere. It's in architecture, it's in history, it's everywhere. And we wanted to highlight how AI is used in different applications, connect them to real world data sets, whether they are from NASA, whether they're from CDC, and then use the concepts of statistics to kind of connect that data, which is kind of the fuel that AI runs on, with different types of AI and how they're used. So the textbook is full of examples. And another interesting thing that we try to do is teach students how to use AI tools as a part of their regular education. And this is also something that Provost Rifkin spoke about this morning. For example, in literally our textbook features something called a Gemini box, but any chatbot can be used. We just use Gemini because it served our purpose well. And so with every chapter, with every topic, we have, we use AI as a pedagogical tool that enables students to type in prompts, and it gives them examples. They can build on these, they can create their own, and gives them the ability to explore topics in greater depth should they want to do that. And we connect every statistical concept that we explain, every machine learning concept that we explain, to the different types of AI and how they use it. For example, there is a lot of conditional probabilities used in agentic AI, for which, one of the leading examples is self-driving cars, which makes decisions on its own. And it's constantly evaluating different types of conditional probabilities to make its decision. And we also teach conditional or explain conditional probabilities from first principles, so that there is no assumption of a earlier learning in different types of courses. So as we know, the process typically entails understanding what the problem is, collecting and storing and retrieving data, and how to summarize it, how to understand it, because that's an important part. One of the things about AI is you have to provide the proper data to the tool. So exploring and understanding it, even though it's a fundamental statistical process like exploratory data analysis, it plays a big part in building these AI tools. And most of us here already know about the machine learning algorithms that contribute to AI. We have heard about a few in the previous talks. And in addition, there is, of course, a focus on that right now, the algorithms are very sophisticated. AI algorithms are very sophisticated, but the data that contributes to these AI algorithms is kind of in question. And one of the leading proponents of AI, Andrew Ng, has said that the next step is trying to figure out how the data that goes into these algorithms. The challenges are not computational, the challenges are more about the quality of the data that goes into these. And of course, all of us have heard about, fairness and bias in ethics. Some of them are intentional, some of them are not intentional, and we have a few examples of those as well. And what I wanted to do in this talk, along with my colleague Geeta, is to kind of give you a flavor of how this textbook works. And our goal is to not only just use these tools, but to be able to understand what makes them work. Because unless we know that, we will not be able to choose the correct tool and use it in the appropriate manner. It's not enough just to take, a bunch of data, throw it into an algorithm and get something out. Because we need to have a deeper understanding of how these algorithms work, what it means, what that stuff is that's coming out. And so the focus of this book is almost entirely on building that knowledge or understanding in different academic groups, for instance. So here's an example. Sports analytics are really popular. We have fantasy games, you have sports betting, and all these decisions are actually made in real time, all these sports betting, poly markets, and all these things. And so there is a flow of large amounts of data in real time at great volumes. And they can be examples like, how teams match up against each other, what are player statistics, who is injured, who is benched, whose contract is coming up for renewal, free agents. So there is so much of information that goes into something simple like using Parlay or any of these sports betting platforms or fantasy games. But the machinery behind it is a huge volume of data that is collected, that is analyzed. And in our book, we explain these in great detail as how these real world data are used using simple statistical algorithms or machine learning algorithms. So for example, if for those of you who've seen Moneyball starring Brad Pitt, it's all based on data. And now thanks to our computing power, it's all on steroids now. I mean, just the volume and the speed with which these things are processed in order to make these real-time betting possible. So here's an example where I'm sure a lot of the audience is using some form of fantasy football or things like that. And that is actually employing AI and statistics behind the scenes, and we don't even know about it. In the textbook, we actually use this example to see how EDA is done using sampling and conditional probability. So this is a real example that a lot of students can get behind. Another example, and this has, of course, life and death consequences, is in fighting, predicting, and managing and treating wildfires. So Google has a tool called FireSat, and the idea there is they have these satellites that circle the Earth constantly. So I think their satellites circle the Earth around 14 times a day, which is much higher than almost many other known satellites. And what they do is they take images of the Earth and they look for changes in these images. They combine this information with environmental data, for example, temperatures, how long the temperatures have been high, time series of temperatures, spatiotemporal data as to, what are the surrounding factors. And they compute these along with the presence of first responders, what kind of equipment are nearby. And by looking at the changes in images of, for example, regions which have a high likelihood of having wildfires, they would compare the different images, and they're able to actually anticipate or predict wildfires at a stage where they're still manageable before they become these huge conflagrations like the one we saw in LA a few years ago. So with this particular type of combination of different statistics and combining them together, enabled by AI, they're actually able to build these applications, predict wildfires sooner, and automatically contact first responders so that these things can be stopped before they became too lethal. The kind of statistics that are used in there is spatiotemporal analytics, including geospatial statistics, multivariate statistics, because you have time series of temperatures, wind speed, location. And also when you have data on this scale, you need to use sampling. So in the textbook, we actually use these to show what type of sampling is used and how it's used. And again, this is something that can be taught from first principles with maybe like a high school math and statistics. So here is everybody's favorite example of Waymo. And this is also discussed in the Russell and Norvig, the Bible of AI. And over there, they start off with an example where the task is to take a person to the airport so that they can catch their flight on time. Now, the question is, do you just, leave 2 hours or 3 hours ahead of time and spend another hour and a half just cooling your heels at the airport? Or do you kind of optimize it and cut it so close that there is a danger of missing the flight? And they take into account not only traffic conditions, congestion routes, they also take into account rare events like what if there is a meteorite that comes and hits the Earth and disrupts everything. That is a low probability event, but these are things that go into the computations and the functioning of self-driving cars. They have to recognize objects. They have to recognize, what is the best route. They have to know, of course, be aware of traffic rules. So all this data is collected. And of course, they have cameras and sensors that sense the environmental conditions. So all this information is collected, processed, and and this is a great example of how conditional probabilities are used to choose the best route to optimize the waiting time versus the certainty of reaching the airport on time. Of course, it's not just statistics alone. There are also other fields in computing like object recognition, autonomous decision-making, rule-based learning, all these working together with statistics and data give this self-driving car the ability to make these decisions and navigate safely. Of course, there are situations where the data that is used is not complete or it doesn't cover all possibilities. There was an instance where the self-driving car was not able to recognize an object, and the object was a human walking a bicycle. It had been trained on humans, it had been trained on bicycles, but it had not been trained on a human walking a bicycle across the road. Similarly, if it has to recognize objects like big trucks, it has to be able to see all types of, be trained on images. For example, things like if there is a truck that's turning a corner, unless it is trained on data that has those kind of images in it, it's not going to be able to recognize it. So here's again another example where the data that an AI algorithm is trained on, as well as the science conditional probabilities, in this case of meteorites coming and hitting the road, have to be taken into consideration for this to be a successful AI application. And again, in the textbook, we use examples like this, real world examples that actually people from different disciplines can connect to and feel enthused about. So that's one of the, when we were writing the textbook, that was something that was actually very, very important to us, that this relatability, for a lot of people, AI is an abstraction. This type of ability to relate AI applications to areas of their interest, as I said, whether it's fashion or whether it's space exploration, to be able to know that AI is used everywhere and it is actually helping us in so many ways can actually take out some of the abstraction and the mystique that surrounds AI. And that was something we wanted to do, was to make people comfortable with AI as an everyday tool that is actually already in so many aspects of our life. And by drawing from so many different disciplines, it actually caters to a very wide set of academic backgrounds. So here's another example. This is one of my favorites. It's about this lunar lander, and it's from a company called Firefly, and it was able to nail an autonomous landing on the far side of the moon in its very first effort. And that's very rare. This is a company that works in collaboration with NASA, and it was hailed as a major success at that time because it's very difficult to do that, to be able to. So one of the things that's important over there is they have sensors on the 4 landing pads. And one of the things that they use is to compute the likelihood of one of the sensors failing. And that's just a binomial distribution, because we know from empirical observation what the probability of a sensor failing is. And so here is an example of a simple old-fashioned distribution, the binomial distribution, that has been used to help this lunar lander land safely on the far side of the moon with using those kind of computational statistics. The kind of data, obviously, that this lander would use is camera feeds, topological information, images, and it also monitors the craft itself, because you need to know that the sensors on the craft itself are working properly. So that's the kind of the data that goes into this computation, and the ability of this lunar lander to land in an autonomous fashion on the far side of the moon. So, and here again, the role of this example is to show that this is something, even simple fundamental statistics play a great role in enabling these AI applications to manage complex tasks like landing on the far side of the moon. So we've spoken about applications, and the book is just full of every section, every topic has examples from real life and the data associated with them. They're all drawn from public data sources which are available. And few years ago, there was this big open data initiative where anything funded by tax dollars had to be open and available publicly. So at that time, there was a lot of data available, and that data made a lot of things possible through crowdsourcing, so that many analysts could look at the data. So the availability of data is an important concern, of course, but in addition to that, there are many challenges associated with data. So we spoke about how statistics is used and how it's important for us to provide the appropriate and data in a proper form to these AI algorithms. That is, how does data go into these AI pipelines? Because that's a very important task. So one of the big challenges of that is that just the variety of data, it comes in really complex formats. So for example, it could be something like looking at a chatbot transcript. It could be like, from the previous talk, it could be like looking at PDF documents. It could be looking at, so when you're asking for a summary of some topic, the AI application goes and looks all over the web, and it can look at web pages, which may have embedded video. For example, we have Anderson Cooper here on New Year's Eve. It might have embedded video, it might have embedded links, it might have a nested structure, it might have a graph structure. And then there are, of course, images. So the point here is that it's important to understand the data and to be able to choose the appropriate one and to provide it in an appropriate format. So the AI data pipelines are very important, and data is a big part of AI. So there are many different forms, and there's video, audio, all kinds of things that's there. And of course, there is data that is generated by AI itself, which is images, AI images. And so one of the questions is, how do you know whether your data is real or fake? So all these questions come up while you're dealing with data. It's not just a nice, rectangular matrix of data that's provided to you. So here's another example, and data quality is...
Dr. Dasu, our
Yes.
session ends at 11:30 and we have one more speaker. So could
Okay.
you,
Yeah, sure.
at the time, thank you.
Yeah, I'll do that. So here's an example of data quality. This is an important part of AI, and this is something that's really close to my heart as well. And so there are two types of data qualities primarily that one needs. One is where data is mangled. So there was an example of a healthcare chatbot, which gave different information to different people. Some people it would advise and say that, hey, just take an aspirin and stay at home. And other people it would say, you need to go to the hospital right now for the same set of symptoms and ailments. And that's because it was trained on very clean data in proper English. And here is a case of a unintended bias kind of sneaking into AI algorithms. And of course, all of us are familiar with fake news. And imagine training your model on data which has such fake information in it. It cannot have a real world view of what the real world looks like. And I think all of us know about the bias and security and privacy issues that are there in AI. And interpretability is another big challenge. For example, the police car doesn't know why it pulled over the other car. And finally, I wanted to give you an example of a hallucination that happened to me a few days ago. I was testing a Zoom link just for 10 seconds, and Zoom came back with meeting assets and said, the meeting focused on discussing real estate matters with somebody named Salt. I never discussed any real estate matters, and I don't know anybody called Salt. And this meeting was all of like 10 seconds because I was just testing a Zoom link. So when you look at your recap from your AI notes, be very careful of what's there. So that's all I had to say at this point. Any questions? These are all testimonials for our textbook from different professors and institutions across the country. Our textbook will be available in July.
Thank you. Any questions from the audience?
When is the book coming out?
July, end of July. And it's available for pre-order. It's published by CRC Press, Chapman Hall CRC Press.
Thank you.
Thank you.
Thank you so much.
Thank you.
Speaker.
Thank you.
Thank you.
All right, we have our last speaker. Speaker 2. So Dr. Jay Choi is from our civil engineering department. His background and research is structural engineering, sustainability, and long-term structural performance evaluation. And today, he and his undergrad research assistant, Andre, will present a machine learning-based diagnosis technique to detect concrete deterioration in building. Thank you. It's all yours.
Can you see my screen?
Yes, we can.
Can you hear us?
I mute that. Yes.
You missed it. Thank you very much. Yeah. Can you hear us? Yes. Thanks for having us today with Andre Rodriguez and myself. This is basically collaborative research with FDU Vancouver campus faculty, Professor Jihol Liu and myself. And He's a graduate student, Tianlu Peng, and then our undergrad research assistant for Andre Rodriguez. So this is very collaborative research, and then at the same time in discipline in civil engineering and also computer science and AI machine learning platform. And I work for industry past 8 years, and then I've been noticed there are issue in concrete deterioration and and that is necessary for the objective assessment of reinforced concrete. And the data set we have is actually real data from the state of New Jersey. And when I went to the actual building and inspection, took pictures, and we had some data filtration at the same time, data processing using real data, not anything about the academic anything. So I will go, before I go over, the presentation will consist of 2 parts. So first part is my introduction and then some other ethical issue in using AI in civil engineering discipline. And then Andre Rodriguez will discuss about the general work of our research. So let me go next one. So as you may aware, ASCE, American Society of Civil Engineers, we do have a code of ethics when engineer. I will not go through everything, but only one thing important is civil engineers hold the safety, health, welfare of the public as paramount in their professional duties. And engineers work for society and environmental profession, and then client employer, and then peers. One other thing is more important. In 2024, ASCE issue policy statement 573, artificial intelligence and engineering responsibility. So engineering responsibility and judgment state that briefly, AI cannot replace professional judgment, training, and experience of licensed civil engineer. The engineer remain responsible for decision in planning, design, construction, operation, and maintenance that affect public health, safety, and welfare, which is alignment to in general ethic in ASCE. Even when AI tools are used in analysis on drafting, the engineer must maintain ultimate accountability for the result and must not delegate ethical responsibility to the AI system. And you will see why I'm going over ethics at the beginning. So number 2, AI is a tool, not a substitute. ASCE emphasizes a tool of AI. It may enhance efficiency, innovation, sustainability, but it cannot assume the role of professional engineering judgment. This is a very, very important statement we have. I go to number 3, protecting public safety, health, welfare. Regardless of the AI involvement, engineer must safeguard of public welfare. So the highway we run every day, bridges we run every day, we don't rely on AI to design and guarantee the safety. Number 4 is understanding capability of limitation. This is very important for our students as well. Engineers are ethically obligated to understand capability, limitation, implication of an AI technology they use it. So the requirement is echoed in ASCE Code of Ethics, again, section 1.8. And also number 5, accountability and transparency. Engineer must ensure clear documentation of the AI uses, validation process, engineering decision, while there may not be formal requirement for the disclosing AI use on our project, ethical principles, favor transparency when AI plays a significant role. The last portion is ethical risk and relate to the AI. So this is very important. So I will go through number 6. Common ethical risk and when integrate AI include over reliance on AI result, potentially exceeding one's competence, bias and data quality issue embedded in the AI training data that may destroy the outcome. So lack of transparency, explainability in how AI generate results, data privacy and owner concern when using sharing AI generated content. So for next, Andre will discuss about the general our research about our general research. Thank you.
All right. Hello, everyone. I just want to begin with the contents page, outlining the subjects that we will be discussing regarding the machine learning pipeline. Begins with a introduction, background, data classifications, methodology, and results and discussion. A little bit of context for this particular project is very, very helpful. As Dr. Choi just mentioned, ethics plays a very important part in civil engineering. I want to discuss one case study about the collapse of a 12-story building in Florida called the Champlain Towers. There were many design faults that were found by investigators post-collapse, including poor grading check in a pool deck area. Which was shown to not be properly designed, leading to a drain that was not shown in the plans. And large cracks could be seen here, as well as poor shear reinforcement in the concrete slab, and insufficient drop panels or supports above negative moment regions or the column areas, which played a big part in the collapse. As you can see here in this image, a structural engineer reviewed and inspected this particular site and explicitly said that these conditions were not satisfactory and that something had to be done. However, oftentimes owners face their own set of issues and they may not see the importance of ethics. Going to move on to the next page and explain the limitations of manual inspection. So visibility, time and budget constraints, and variations in experience very much so control the manual inspection. Oftentimes, these symptoms are difficult to find and difficult to reach. Some of these members are hidden away or tucked behind walls, and they're crucial to supporting the structure, and they may not be easily accessible to the eye. Time and budget constraints are very important for owners. Oftentimes, owners may see it as an extra expense to hire a licensed professional over a specific amount of time. Depending on your region, some governments and ordinances may require it for high-rise buildings above a certain amount of stories to be done on a regular basis. This is post this 2021 incident. It's becoming more and more popular that the government is requiring these sort of inspections. And of course, experience can change the ability for a person to be competent at inspecting a particular structure. A little bit of background on this particular project. As we looked at this case study, we see a growing opportunity for objective decision-making in maintaining structures. So the focus on the data used in this particular project is common deterioration patterns that are found in buildings in particular. And the model's task is to distinguish these predetermined classifications of damage to be able to predict whether this particular type of damage is very, very critical, or is it just sort of getting to a point where it should be inspected.
So one thing I'd like to add here, this image over here is showing it's not a damage. You see the reinforcement in the concrete. This is basically poor vibration, poor formwork. So no damage, but AI can detect as damages because if they see the reinforcement. That's going to be false positive and or true negative cases detection.
I'd like to also talk about the governing bodies for concrete analysis. So the American Concrete Institute is a resource that in the curriculum here at FDU, as well as industry, both uses for guidance on various different concrete technical information, such as concrete control, crack control, and design and reinforcement detailing to limit that cracking. The damage in these inspection photos are oftentimes, as Dr. Choi just mentioned in the previous image, are difficult to scale reliably. So these cracks may not be the same width depending on where this person is shooting the image. It could be maybe 10 meters, 20 meters, whatever, however far you're taking it could change the thickness of the crack. And it may give more trouble for the machine learning model to accurately predict certain cases. So the classifications will be determined on signatures that are observed in the field and common symptoms that are associated with these types of deterioration. So the AI-driven inspection pipeline has these three key steps. We talk about the deep learning-based classification using neural networks to learn these patterns from the raw data. As we were seeing in these previous images, a lot of times these common forms of deterioration have these symptoms that are very, very easily recognizable. And you'll see a little bit later when we discuss the results that certain damage classifications are easy for the AI to detect because they are very, very obvious, whereas others may have a little bit of struggle. The post-filtering process of cleaning and smoothing, as well as the analysis of the actual distribution of the data and common trends at the AI model AI model's decision is based off of. These are the dataset classifications. I just wanted to also mention that there is a no damage classification as well. The no damage classification is not listed here. However, it is the first step of the decision making by the AI. Is there damage present or not? And then it would go further into classifying the actual damage. The first being minor cracks, we aforementioned as being very difficult for the AI to kind of distinguish. As you can see in this image, it can be kind of hard for you to even see visually. And the next step is the efflorescence, which is a very, very big indication and very important for the machine learning model to distinguish because it proves that there is movement of a medium beneath the concrete, say water or some other sort of liquid that's carrying salt deposits or other kind of chemicals that could damage the reinforcement and corrode it further. So if you see these white deposits, it's a clear sign that there is some sort of movement of water in between. And as we move to the very next section, you can see that that similar crack now has exacerbated to have clear, corroded brownish color surrounding the crack, which means that now the reinforcement is beginning to swell and the corrosion is passed through that crack. And the very, very final section is the severe corrosion associated with the concrete where it's actually spalled and sections have been removed off of the concrete and the reinforcement is completely exposed and corroded, which can be very crucial because concrete is a brittle material, so it fails suddenly. It relies on the reinforcement for its ductility and its extra strength. When we were first looking at this data set, one of the very first steps was actually manually going through and organizing these images based off of what we believed was the damage. And so these file names were used in organizing each individual classification, and they are listed on the screen. This is the methodology for the inspection framework. It begins, as we mentioned earlier, with the collection of data, moves on to the sorting, and then, of course, the pre-processing, which I find is a very interesting component of the image standardization, where these images, to avoid overfitting, have undergo some sort of augmentation to flip them at random to make sure that the machine learning model can still accurately predict these results, even with varying complications, slightly tilted or turned around in some sort of way. And in the coming slides, we'll discuss a little bit about the architecture as well as the validation. The ResNet 50 architecture is what was used for this particular project. It is a deep neural network that has a distinct feature of being able to pass information through layers while also skipping certain layers that depending on whether it finds them to be useful. This image on the screen, as you can see, figure 10, does a very good job of explaining each step along the way. The results and discussion section is we found 80% accuracy on the independent test set, finding, as aforementioned, that the biggest struggle is the minor damage category, where it comes in at sort of the weaker metrics, where it's a little bit of a struggle there in determining that.
So if you want to see on the data, minor crack and spalling, F score is only 0.57. So we only 57% of the higher accuracy as compared to other cases because of the lacking of the images, very minor crack, there is a crack, but AI cannot recognize because of the quality of the picture. There are different patterns and they doesn't train that well. So that's a one highlight there. And then
this is the confusion matrix. It also kind of gives a nice visual representation of this, as you can kind of see. It highlights where these misclassifications occur. You can kind of see in this particular region here. I find this to be a great visual resource. And the failure case is something that we wanted to go over to highlight the limitations of AI. A lot of times these photographs are taken quickly in the field and other elements such as mechanical equipment in this photo are corroded, but there is actually no corrosion or damage to the concrete. So at a glance, you would say, okay, the concrete looks good and you'd know there'd be no damage, but the machine learning struggles because of that major pattern associated with that corrosion being this rusty brown that is found here on this pipe. This is an image to highlight the annotation. The annotation was done by a Python tool, which was, as you can see, this kind of green line here would kind of separate that particular area of corrosion, make it a little bit easier for the model.
So I think the annotation is next our future work to improve our F score ratio, because after you do the annotation, you remove unnecessary data set to the AI. So the only information we can give them AI is a correct area of the information. So for example, the pipe area we looked at before, we can remove that by annotation technique. But it's very handy. There's a lot of tedious work because we are handling more than 1,000 or more data set. So go ahead. It's your turn.
Okay. This particular research is under review for the 11th Forensic Engineering Congress coming up in October. So we're currently still awaiting the information for the peer review, but this is very exciting for us.
So this work is basically accepted by ASC 11 Forensic Congress by presentations. We are going to Orlando coming October, and then so current conference paper is under review, and then you can go next.
Okay. Thank you, everyone. We have our references listed here. If you have any questions.
Any questions from the audience?
The annotations, are you using AI to do any of the image recognition for annotation after, let's say you've decided you've already sorted it? Can you take the sorted minimums and say, hey, AI, now annotate for us so we can go and use it to build?
Well, we have not, but that's actually an interesting point.
But the question is, can we rely on AI to do annotation?
Yeah.
And or not, right?
Yeah.
I haven't seen any programming yet to automation process of annotation.
We should talk after this.
Yeah,
I can build that for you.
Yeah, but right now, actually, Andre and other students have been helping out us to do the annotation by manually.
Yeah.
I know it takes time consuming, but at the same time, as engineering student, it's a great learning experience because they're looking at actual picture and then they are actually training as a human.
So this process in certain cases is automated?
It's just entirely just based off.
Very cool.
Yeah, Dr. Troy, I focus that the maintenance and inspection is going to be a way harder AI case than actually the design. I think we get to actually the design case way faster. I mean, we're already have built 50 agents that can design structures that we've learned that rather than train them on human designs, if we actually train them as engineers and then let them do design and iteration, they actually come up with far superior designs. We can take a design set now from conception to 80% in about 6 hours, and then give the entire assumption set to my engineers to actually then do the human in the loop verification of all calculations and signing and sealing. Pretty impressive.
Yeah, thank you very much.
Well done.
Thank you very much.
Good luck in October.
Thank you.
Thank you so much.
I stop sharing here.
Dr. Mao, I think you can ask questions later in person. I think we have to wrap up to stay on track. So thank you, everyone, and please join the next Zoom room for lightning talk by students. Thank you so much.